Chatellier's principle. Chatellier's principle is also known as Chatellier's principle or the equilibrium law. Chatellier's principle is the principle when a stress is applied to a chemical system at equilibrium. The equilibrium will shift to relieve the stress. In simpler words, it can be used to predict the direction of a chemical reaction in response to a change in conditions of temperature, pressure, volume, or concentration. One of the factors affecting equilibrium is concentration. If the concentration of one of the reactants, A or B, is increased, the system will shift the reaction in a direction that uses up the species added. Therefore, the forward reaction is favored. In other words, the equilibrium is pushed to the right and more products are formed. If the concentration of one of the reactants A or B is decreased, the system will shift the reaction in the direction that uses up or consumes the species added. Therefore, the forward reaction is favored. In other words, the equilibrium is pushed to the left and more reactants are formed.
The second factor affecting equilibrium is temperature. Forward reaction is an exothermic reaction. Therefore, an increase in temperature will cause the system to absorb the extra heat. It favors the endothermic reaction. Raising the temperature shifts the equilibrium in the endothermic reaction. Secondly, reverse reaction is an endothermic reaction. Therefore, a decrease in temperature will cause the system to release more heat. It favors the exothermic reaction. Lowering the temperature shifts the equilibrium in the exothermic direction.
For the pressure can be changed by changing the volume at constant number of mole is N. Changing the number of mole N at constant volume. Consider the equilibrium. N2O4 change to 2NO2 from 1 mole gas molecule to 2 mole gas molecules. At constant V, the reactant side exerts less pressure and is less compared to the product side. An increase in external pressure will cause the reverse reaction to be favored, thus shift the equilibrium to the left.
Now, moving on to the next factors, which is catalyst. When a catalyst is added to an equilibrium mixture, it speeds up both forward and reverse reactions. In other words, the forward to reverse ratio remains unchanged. The relative numbers of reactant and products at the equilibrium remains the same. Therefore, introducing a catalyst has no impact on the equilibrium position.
Next, the second application of daily life is everyday tasks like drying clothes are also examples of Le Chatelier principle and a chemical equilibrium in real life. On a windy day, the water vapors are carried away faster. Now, to establish an equilibrium, the water from the clothes starts drying, hence drying the clothes.
Alright, for the application 2, everyday tasks like drying clothes are also example of Le Chatelier's principle and chemical equilibrium in real life. On a windy day, the water vapors are carried away faster. Now, to establish an equilibrium, the water from the cloth start drying, hence drying the cloth.
Next application is melting of ice. It is clear that the reaction is endothermic and accompanied by a decrease in volume. This reaction indicates the formation of liquid water takes place with decrease in volume. Hence, increase in pressure favor forward reaction. Since it is endothermic, so increasing the temperature will favor forward reaction. Due to the increase in temperature, heat will be absorbed by the reaction.
Moving on to the next application, which is boiling of water. It is clear that this reaction is endothermic and accompanied by an increase in volume. The formation of liquid water takes place with increase in volume. Hence, increase in pressure favor forward reaction, principle of pressure cooker. Since this reaction is endothermic, So increasing the temperature will favor forward reaction. Due to the increase in temperature, heat will absorb by the reaction.
And lastly, the importance of Le Chatelier's principle. Industrial processes like making fertilizer or sulfuric acid are all about maximizing profit. To do this, we need to get the most product we can while keeping costs low. Le Chatelier's principle helps us increase the yield of certain products in reversible reactions and make more money. However, we can't just focus on the yield. We also need to think more about factors like temperature and pressure. Lowering the temperature might increase yield but make the reaction too slow to be useful. On the other hand, increasing temperature or pressure could be too expensive. That's why we use compromise conditions. They balance all these factors to find the best option.